for the agency's Commercial Lunar Payload Services, or CLPS initiative. I'm Natalia Rusek from NASA's Office of Communications. Today's briefing will cover the NASA payloads on board Firefly Aerospace's first flight to the moon, Blue Ghost Mission 1. This flight is scheduled to launch no earlier than Wednesday, January 15th at 1:11 a.m. Eastern. This briefing will highlight the NASA science investigations and technology demonstrations flying aboard Firefly's lunar lander named Blue Ghost. Our briefers today are Chris Culbert, Program Manager for CLPS, NASA's Johnson Space Center, and Maria Banks, Project Scientist for CLPS, NASA's Goddard Space Flight Center. First, we'll start with some initial remarks from each of our briefers before opening it up for questions. We'll be taking questions on our phone bridge, so if you've joined us today, please press *1 to add your name to the queue and ask a question. We'll now begin with opening comments from Chris Culbert. Thank you, Chris.
Thank you, Natalia, and thank you, everybody, for joining us. Welcome to 2025 and another year of NASA science and technology being delivered to the moon. This launch will mark the third lunar delivery under the agency's CLPS initiative. We hope to have a couple more launches and landings later this year. This is Firefly's first attempt to deliver NASA payloads, and it's the largest group of payloads manifested on a CLPS flight to date. There are 10 payloads covering a wide range of science and technology investigations that will help NASA prepare for sending humans back to the moon under the agency's Artemis campaign. The 2 lunar deliveries attempted in 2024 demonstrated that these small and innovative American CLPS vendors have the technical capability, but landing on the moon is very, very hard. We know this can be challenging, but while we've been quite impressed with Firefly's preparation for this mission, it will be their first lunar mission and landing. We look forward to Firefly overcoming any challenges and obstacles they may see. Through CLPS, NASA is buying a complete commercial robotic lunar delivery service, meaning, in this case, Firefly is responsible to procure launch services, develop and design its lunar lander, build the lunar lander, lead landing operations, and send science data back for analysis. The CLPS initiative aims to conduct science on the moon for the benefit of all, improving our understanding of the lunar environment and surface characteristics in advance of future crewed missions to the moon. Under this innovative model, NASA is one of many customers, buying a delivery alongside commercial companies, universities, and international partners, all with the goal of sending payloads to the moon. Now, this can be very risky. With CLPS, NASA is embracing a higher level of risk tolerance by leveraging commercial solutions to send rapid, low-cost deliveries to the moon, fostering a growing lunar economy. On behalf of NASA and the CLPS initiative, we wish Firefly Aerospace the very best for this mission. Back to you, Natalia.
Thank you, Chris. We'll now hand it over to Maria Banks.
Hi, everyone. Thank you so much for having me here today. So I am the NASA Project Scientist for Blue Ghost Mission 1. I will be in Firefly's Mission Operations Center working on console to work with Firefly and our payload teams as we conduct our instrument operations. One of my jobs is to ensure we maximize our science and technology goals and objectives as possible. So with 10 NASA instruments on this flight, we're looking at scientific investigations with a wide range from characterizing Earth's magnetosphere to understanding lunar dust and characterizing the structure and thermal properties of the moon's interior to demonstrating technologies that improve navigation and computing in a higher radiation environment. But before I give you, I'll talk in more detail about this science and technology, but I want to first tell you a little bit about the landing site. So the landing site for this mission is within what's called Mare Crisium, and that's a basin located on the moon's near side. It's a large basin, approximately 340 meters or 550 kilometers in diameter or width. And so you can actually see it with your naked eye as you look up at the moon. So our landing ellipse is located near an interesting volcanic feature called Mons Latrell, and I'm really excited about that. And it should hopefully be visible from the lander while on the surface, it's just off in the distance on the horizon there. So this landing site, it allows NASA payloads to gather data about the moon's regolith and geophysical characteristics, and this particular location avoids magnetic anomalies on the lunar surface that could disrupt some of our payload measurements. And additionally, we conducted analysis on data from Earth and a NASA orbiting spacecraft, and that analysis indicated that there's very few rocks on or below the surface. So this hopefully will allow for safe operations of a drill that we have on board. So with that, I want to talk a little bit more about the science and technology. The NASA payloads on the Firefly's Blue Ghost Mission 1, they'll help to advance lunar research and conduct several first-of-their-kind demonstrations, which will collectively strengthen our understanding of the moon's environment and, importantly, help prepare for human missions to the lunar surface. So we'll be testing the ability to use Earth-based global navigation satellite systems, such as GPS, and route to and on the surface of the moon. We're going to be testing radiation-hardened computing systems to improve computing technologies that can be used also on the lunar surface, but also in deep space. Other scientific investigations will use X-ray imaging to study the interaction of the solar wind and the Earth's magnetic field. And we can use this data to inform decisions on Earth about weather predictions, to protect GPS and satellite connectivity, and prevent power outages caused by geomagnetic disturbances and storms. Instruments will work together to characterize the structure and composition of the moon's mantle by measuring electric and magnetic fields, and also characterizing the heat flow from the moon's interior with measurements up to 2 to 3 meters. That's up to 9 feet below the surface using a pneumatic drilling technology. And I also want to talk about lunar dust. As we experienced during Apollo, the moon's surface is quite a dusty landscape. And as we design our technologies and experiments for the lunar surface, regolith dust, we need to understand it better. It can affect mechanical components. It can cause degradation of Earth-based materials and, importantly, impact our human health. So we want to know how best to account for its effects. So several payloads on board will be helping us to study this. We'll be looking at how dust adheres to various materials, testing a regolith sampling technology. We're taking stereo imaging as we descend to the surface to see how the rocket plume is affecting the lunar regolith. And we're going to test the usage of electromagnetism to mitigate or prevent dust buildup. So as Chris mentioned, the NASA payloads on this delivery represent the largest number of NASA payloads manifested on CLPS task order to date. And I want to highlight quickly that these payloads, they come from all over the United States, including Montana, Texas, Maryland, California, 3 NASA centers, and significant contributions from the Italian Space Agency. So thank you, and back to you, Natalia.
Thank you, Maria. And thanks to our briefers for those initial remarks. For awareness, we also have some additional NASA subject matter experts on the line in case there are some specific science investigations, technology questions that come up. We'll now open it up for questions. Again, for those on the phone bridge, please press *1 to submit a question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, press *2 to withdraw it. Our first question is from Will Robinson-Smith with Spaceflight Now.
Yes, hi. Thanks for taking the time to talk with us today. Question for Chris, sort of as a kind of a high-level one. Around when do you expect the NASA payloads to complete their operational checkouts following stage separation? And when do you expect to start receiving science data from the majority once they're on the surface of the moon? Thanks.
So Firefly has a relatively long transit to the moon, about 45 days. The payload check, all the payloads will be checked out during transit, most of them fairly early after launch, typically within 2 to 7 days after launch for most of the payloads, though some payloads will wait a little longer and some will do a second checkout as we get closer to the moon. Some of the payloads will actually gather data on the way to the moon, which is also, so we'll be getting scientific data back throughout the mission. Once we get to the surface, we expect, Firefly has to go through the process of landing, confirming they've got comm, confirming that the lander's in good shape, and getting their power set up. So it's typically going to be a few hours before we start getting science data back from the NASA payloads. But Firefly and the NASA payloads, particularly with Maria's team's help, have put together a fairly well-defined plan for how we get everything up and running once we're on the surface. and that plan helps maximize science return from all the payloads. So we should be getting data within a few hours that will last for almost 2 weeks till we run out of sunlight on the moon.
Thank you, Chris. Our next question is from Jeff Faust with Space News.
Yeah, good afternoon. This is a question probably for Dr. Banks. Since you have a large and diverse set of payloads on the lander, are there any sort of special issues or complications in terms of coordinating the activities of those experiments so they all get their data back in a timely manner?
Well, sure. With 10 payloads, of course, we want to be always aware of the lander resources. And so planning the operations, I want to give a shout out to Firefly, who has been just fabulous to work with on this. It's very tricky, of course, to plan around limited resources to make sure everyone gets what they need at the time that they need it during the mission. So it's also been really important to understand the different science and technology goals and what periods of the mission are most important for those to function so that we can make sure we operate everything when we're supposed to operate them and work together to coordinate those resources. And some instruments need to interact together in certain ways. For example, I mentioned that we have a lot of experiments that are looking at dust. And so we're looking at how dust adheres to different surfaces. And so we want to, some of the instruments will disturb the regolith, say our drill, for example. And then we want to make sure we operate these at different times corresponding to other instruments that maybe want to understand, both want to see how that regolith gets disturbed and maybe adheres to surfaces differently, or also to conduct their experiments, say, before that happens. So coordinating those different kinds of things, making sure everybody operates when they need to, make sure we're cognizant of those resources, and then the order in which things happen to make sure we preserve the science we want to capture.
Thank you, Maria. We're now going to hear from our principal investigators for each of the payloads, starting with the PI for LMS, Bob Grimm.
Hi, I was not aware that I was to prepare remarks. I thought we were just answering.
Thanks, Bob. Yes, we are waiting for further questions from the media, so we'll move on to the next payload. PI, if you would like to share some remarks, Lou Gray.
All right, thank you. So this is James Miller in Space Operations based out of NASA headquarters. I'm the sponsor for the group. And I have to say that we're extremely excited about this opportunity. We're very grateful to CLPS and to Firefly. We are flying the first GPS/Galileo, so we call it GNSS, receiver to the moon. We know already that we are able to process signals halfway to the moon, but by actually doing it in lunar orbit and the lunar surface, we're opening up an entire new way for us to navigate in the future. This will support Artemis. It's a great collaboration with the Italian Space Agency. And again, we're really looking forward to how far we can go in using space assets to support lunar missions and people on Earth. Thank you.
Thank you. As a reminder again for those on the phone bridge, please press *1 to submit a question. Once your name is called, please state your name, affiliation, and to whom you'd like to direct your question. If you find that your question has already been answered, please press *2 to withdraw it. We'll now move on to our next payload principal investigator. Let's hear from Charles Buehler.
Hello, this is Dr. Charles Buehler. I am the principal investigator for the electrodynamic dust shield here at the NASA Kennedy Space Center. The electrodynamic dust shield is a technology developed here at Kennedy Space Center over the last 25 years, which can lift and remove dust from surfaces. Using active technology, we apply a signal to a surface. that we have embedded electrodes into its surface, and we apply that signal, and it lifts and removes dust without moving parts, gases, or fluids. We're very excited to see this technology finally work on the lunar surface using actual lunar regolith, and demonstrate that it does work in the harsh lunar environment with the highly charged dust and the and the difficult dust that is on the moon. That's very abrasive and very has very high, strong adherence characteristics. Obviously, that's very important for the Artemis mission and the future missions to come on the moon. If you need to keep surfaces free of dust, whether it's an optical system or a solar system or whatnot, but we definitely look forward to working with Firefly to get this technology demonstrated on the moon in the next few weeks. Very exciting times here for us at KSE. Thank you.
Thank you, Charles. I'll now hand it over to Dennis Harris to talk about the payloads on board.
Before I get started, this is Dennis Harris, I'm the mission manager out of Marshall for 5 of the 10 payloads. Before I get started, I'm going to turn it over to Dr. Brian Walsh, who's the PI for Lexi, and let him have a few comments.
Thank you, Dennis. Brian Walsh here from Boston University. The Lexi payload will take the first global images of Earth's magnetic field. We're extremely excited to see this. There's a whole bunch of reasons you might want to do this scientifically. One great way to understand this is by looking at the analogy of exploring the Earth. And we're sitting here in Florida right now getting ready for launch, not too far from the Florida Everglades. And if you wanted to study them, you could send some explorers out there with all kinds of devices, marching through the swamps and measuring water in a lot of detail and counting trees. But fundamentally, you'd understand something completely different if you just flew a helicopter and you took images looking down. You'd get a whole global picture of flow patterns of different trees and different fauna and wildlife, and that's what we're doing with Lexi. We're taking the first global image of the magnetic field to understand how it moves as a function of time in response to the sun and the flowing solar wind.
Thanks, Brian. Dennis Harris again from Marshall. A few words about, we'll just riff off of EDS for a minute. I'm the mission manager for RAC, which is the Regolith Adherence Characterization Project. It's going to fly 15 different samples of varying materials, everything from spacesuits to Teflon to optics. And the idea here is to look at how the very abrasive regolith adheres to these different materials over time. It's a fairly simple setup. It's a wheel with the 15 samples, and once a day it will rotate and take images and send those images back to the individual PIs who sent them up. I'm going to move on to NGLR, which is a next generation retroreflector built by individuals and University of Maryland, actually some of the same individuals who worked on the Apollo retroreflectors in '69. Its job is to be a target for ranging stations across the planet to shoot lasers and get the return and make a measurement of exact distances between the moon's surface and the Earth. And over time, they look at how that surface moves to understand better the inner workings of the moon, as well as understanding, that will lead to a better understanding of several things concerning the moon and about cosmology, which you can talk to Dr. Curry about in the future. Thanks. I'm going to turn it over to Mike Selby for a minute.
Great. We have a question from Marcia Smith with Space Policy Online. Your line is open, Marcia.
Thanks so much. My question is about the dust. Is the expectation that the dust is exactly the same every place on the moon, or is it different in different locations, like the South Pole versus Mare Crisium where you're landing? And how important is it to get these dust measurements? If something does go wrong with this mission, do you have replacement experiments on future landers?
Maria, I think that would be directed to you.
Sure thing. I am going to say that one instrument that will be flying on other landers that's looking at dust is SCALP. And actually, we have Rob Maddock on from the Scalps team, and I would like to turn it over to him to give him a chance to talk about Scalps, which will be flying on several missions, and address the question about dust on the lunar surface and our understanding of that and how the distribution of that dust on the lunar surface. Rob, would you like to proceed?
Sure. This is Rob Maddock. I'm the project manager for the Scalps instrument on the CLPS lander on Blue Ghost 1. As Maria mentioned, I'm certainly not a dust expert, but I have been working plume surface interactions, including the Scalps payload, for quite some years now. To answer your first question, no, we don't expect it to be exactly the same everywhere. We do expect there to be some differences between, say, equatorial landing sites and polar landing sites. And that's one of the reasons why we want to take an instrument like Scalps and actually fly it as many times as possible to as many different locations so that we can get a sampling of how plume surface interactions occurs under different conditions, different surface conditions, and as well as different landers. This will actually be our second flight of this payload. We also flew on the Intuitive Machines 1 mission. And as Maria had mentioned, we also have payloads kind of planned out into the future as well. And so one of the things we do want to understand are how does this dust interact with the thruster plumes and how that varies with lander size, engine thrust, location on the surface, number of thrusters, anything that we can think of, with the hopes being that we can understand a way to model these kinds of effects and use that information going forward into Artemis and HLS to design better landers, safer habitats, safer surface assets on the ground, and just to protect the science and the assets that we have in the area. Ryan, if you wanted to add anything to that, you're welcome to.
Rob, I think you handled that question very well. I think, the short answer is no, we don't expect the dust to be the same, but that's one of the important reasons we're flying some of these instruments is to take those measurements and find out if that really is the case.
Thank you, Ryan. Our next question is from Ryan Caton with NASA Spaceflight.
Hi, thanks. So it seems there are a number of payloads on board related to the lunar regolith and how the regolith interacts with various materials. Is this data and science just being collected generally for NASA, or is it also going to be shared directly with companies such as Axiom with their development of the AX EMU suit for Artemis and beyond? Thanks.
Hi, this is Maria Banks. I will. Oh, go ahead, Chris. I'll let you do it, Chris, and then I'll jump in.
We'll need Maria for the technical part, but in general, NASA as a public agency largely shares data, but there are some circumstances where that isn't entirely true. And then it also is, the data is relevant to how you collected it and how it needs to be used, right? So let me turn it over to Maria to talk a little more about some of those things.
Sure thing. So all of the instruments will be sharing or making this data publicly available at anything that isn't proprietary, that doesn't, I think that's what, I'll let Chris speak to that. That's the one difference with doing a commercial mission. But all of the science data will be made publicly available and publicly accessible to everyone. And one archive that most of our instrument teams are using is called the Planetary Data System, or the PDS. And so all the data will be publicly available there, along with documentation and such that everyone knows how to utilize and interpret that data. And so in turn, any commercial company could go get that data and use it for their purposes anywhere, not only American companies, but anywhere in the international community as well.
Thanks, Maria. I'm now going to pass it to one of our payload mission managers, Mike Selby.
I'm Mike Selby. I'm the lunar payload manager for the Lister payload and the LMS payload. On behalf of Dr. Saichi Nagahira from Texas Tech, the principal investigator for Lister, they're very excited about this opportunity. Lister is a pneumatic drill that's going to drill down to a depth of 3 meters, hopefully, and hopefully make measurements of thermal conductivity at various increments as it drills down. The LMS instrument, Dr. Bob Grimm is here. From SWIRI, they are going to make magnetic and electric field measurements of the lunar subsurface to learn about the history of the development of the moon. And one thing I'll point out is the LMS and Lister instruments versions of those are also flying together as an instrument suite on a successive CLPS mission, and they'll be able to get some of the same information in a different location on the moon and compare and correlate that information.
Thanks, Mike. While we wait for more reporters to submit their questions in the queue, Chris, I was wondering if you could tell us a little bit about these small American companies who have never done this before. Can you talk to us about the risks of CLPS?
Sure. So let's start with some big picture stuff, and then we'll get some details. So on the big picture scale, CLPS is a contract with 14 different companies. Many of them are very small companies, like Firefly and Intuitive Machines, Astrobotic. Some of them are much bigger companies you might recognize, like SpaceX or Lockheed Martin. The way CLPS works, we define a manifest and then let each of those companies compete for the opportunity to deliver that manifest to the moon. We've been in existence for about 6 years now. We've awarded more than 10 task orders for deliveries to the moon. We had 2 attempts last year, both by small companies. Astrobotic was the first one, and Intuitive Machines was second. Not all the companies in our pool have won task orders, but we've awarded multiple task orders to a handful of them. At this stage, they're all in various development phases, getting their landers built. Each mission tends to be different, unique, because the instruments are all different, coming from different sources, different requirements, different capabilities. The landers are largely, each vendor builds its own lander, and the landers don't change all that much from lander to lander. So the companies are learning lessons, and what we expect and what we think we're seeing is that as they, go through the process of developing a lunar lander for the first time, and I'll remind anybody, nobody in the United States has built a lander since the 1970s. Most of those engineers are long gone. They're not helping us build these landers anymore. But NASA did a good job back in the 70s, the Apollo era, of leaving a lot of data behind. What we've seen is that these companies have not only learned from that, but they tend to be relatively small, very innovative. They've come up with unique ways of solving these problems at much lower cost or taking advantage of new technology. Obviously, technology has advanced a lot since the 1970s. And in some cases, at least, it didn't entirely successful. But we'll acknowledge that's very, very hard. There's a lot to learn. It's not just the environment, what they and we're really impressed with the way they're able to come up with solutions at relatively low costs. The life cycle, with their own way of doing things, and we've seen some good stuff, and we're just accepting that at least their first try, maybe they won't be fully successful.
Thank you, Chris. And another question for you. Can you highlight how this flight fits into the calendar this year? What else is on the horizon for CLPS? Sure.
So we've been awarding around 2 task orders per year since 2019. We had 2 up this week. Intuitive Machines were ready for their second sometime this first quarter of this year. Intuitive Machines' third mission will probably be ready close to the fourth quarter of 2025. Astrobotic is working their second mission. It could be late this year. My guess is it's more likely to go into next year, 2026. And then we would have at least one, Firefly's second mission and Draper's first mission that could go up in 2026 if they're ready.
Thank you, Chris. This next question is for Charles, the PI for EDS. What will happen if no dust gets on the electrodynamic dust shield during landing? Do you have a backup plan?
Yes. When the EDS hits the surface, there's no guarantee that we will get dust on our glass and thermal radiator EDSs. So what we've done is we've developed a reduster technology which can lift dust from the lunar surface without moving parts, without gases or fluids, lift it up and transport it to our EDSs so we can show that EDSs can get dust off of them. The reduster technology is developed for that.
Thank you. Now I'll pass it over to J.J. Miller to tell us more about the international collaboration.
Thank you very much. Just as we just raised the point that this is really new opportunities for small companies, it's also really important opportunities and new experiences for some of our international space partners. So OSSI, or the Italian Space Agency, we have been very close with for a number of years. Of course, they're part of Artemis, and I think it's really important to state that this is the first opportunity that Italy, as a nation, has been able to actually put a piece of hardware on the moon. And so it's my understanding that the director of OSSI has actually briefed the Italian Prime Minister on this, and we're quite excited. Italy, as a nation, will recognize this great achievement. And again, thank you to the CLPS program and Firefly for providing this very important international partnership opportunity.
So this, Chris Culbert, again, I'll add on to that. The Italians are flying on this mission, but we, in the future, will have payloads for the Canadian Space Agency, the European Space Agency, the Korean Space Agency. We've had discussions. Mexico Space Agency flew a payload on Astrobotic's first mission. While NASA is focusing on our payloads, the opportunity through these commercial companies is allowing an awful lot of international cooperation and other payloads to get to the moon. We think that's a really exciting development.
Thank you, Chris. Thanks to all who submitted questions, and thanks to today's briefers for taking the time to discuss NASA's CLPS initiative and Firefly's upcoming mission, Blue Ghost Mission 1. As a reminder, Firefly is scheduled to launch aboard a SpaceX Falcon 9 rocket no earlier than Wednesday, January 15th at 1:11 a.m. Eastern. Thanks again for joining. That will wrap up today's briefing.
Thank you. That concludes today's call. You may disconnect at this time. Host, please stand by for your post-conference.